Welcome to Investigation 3.1, Exploring Triangular Numbers. In this focus question, we are going to be focusing on how many dots are in the nth triangular number. And more specifically, we're going to actually call this, instead of dots, we're going to say squares. We are going to be looking at the concept of triangular numbers, which are essentially a way that we can see quadratic equations develop and find patterns within those quadratic equations. We're going to play around with throughout this whole investigation for 3.1, 3.2, 3.3, and 3.4, looking for patterns to prove if something is a quadratic equation or not, and then also playing around with different sort of equation building. So let's get started. For this investigation, we're dealing with triangular numbers, and we're going to be dealing with them in the form of steps. And so what I mean by steps are these figures. If you look at them, they kind of look like a staircase. Our first figure, we have one step. In our second figure, there's two steps. In our third figure, there's three steps. But we also need to look at how many blocks make up those steps. So our first figure, it is made up of one block. Our second figure, we have 3 blocks. Our third figure, we have 1, 2, 3, 4, 5, 6 blocks. And we can see our steps develop. So our first 3 triangular numbers, we can say are the following. We can say figure versus blocks. And the triangular number is the number of blocks that are in each figure. So our figure number 1 had 1 block. Our figure for number 2 had 3 blocks. Oops, I did it in the wrong color. 3 blocks. And our figure for number 3 had 6 blocks. So now we're going to actually look at this and we're going to create a couple of more steps. I want to find and draw the next 3 triangular numbers. So if I were to say I need a figure number 4, I need to make a figure number 5, and I need to make a figure number 6. I should be able to create those various steps. So what I noticed in our last figures, let's look at these. In our last figures, for figure 1, there was simply 1 block. For figure 2, it was a 2 by 2 top and across the bottom and the top, or base and height, I should say. In figure 3, we had 1, 2, 3 by 3. So my fourth figure is going to be the same sort of thing. It's going to be a 4 by 4, and I'm going to stack the blocks smaller and smaller by 1 on each step. So my figure number 4, I imagine I'm going to be drawing it as a 1, 2, 3, 4 steps tall, and it's going to be 1, 2, 3, 4 steps across. And now I need to erase a little bit of extra so that way I can make sure I'm only showing the steps I need to show. So that's my figure number 4. My figure number 5, I'm going to draw way over here so I have a little bit of room for my figure number 6 below. My figure number 5, I'm going to draw over here, and it's going to be 1, 2, 3, 4, 5 steps up. And it's going to have 1, 2, 3, 4, 5 steps across, and now I'm going to erase the extra. So as I look at this, as I think about this, I'm kind of making a triangle that is an isosceles triangle, because I have the same number along the base as I do along my height. And so that's kind of cool. These triangular numbers are almost isosceles triangles. My figure number 6, it's going to follow that same sort of pattern. So I'm going to have 1, 2, 3, 4, 5, 6 rows, and 1, 2, 3, 4, 5, 6 columns, and then from there I'm going to erase my extra. So I'm just making those triangular steps. So now from there we can actually count this. I can figure out how many steps are in my next triangle. So for number 4, we have how many blocks. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 blocks in the next step. The figure 5, we have 1, 2, 3, 4, 5. And if I look at this, I just added 5 to what was on my fourth block. So I know I had 10 here, and I'm adding 5, so I actually have 15 blocks. So that's my pattern that I'm starting to see. My next one, here's my fifth step, my fifth figure, and I know that's 15 blocks, and I'm adding 1, 2, 3, 4, 5, 6. So I'm adding 6 to that, so I have a total of 21 blocks. So that's kind of cool. I've now found all of the numbers that I have going on for 1 through 6 figures, and I figured out the total number of blocks for each of those. My next step, it says below, make a table of values for the first 10 triangular numbers, and I need to ID what the pattern is. So let's make that table. I have my figure that I'm going to add here. I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm going to write down the blocks there as well. I'm going to fill in this table with the first 6, and it'll be math magic here soon. So I filled in my table, and we know when we make tables we're looking for patterns, so we need to look at this pattern and we need to identify what we have going on. From 1 to 3, I could say that I'm multiplying by 3 or I'm adding 2. But I need to find what that pattern is. So I'm either adding 2 or we're timesing by 3. If I look at the next one, 3 to 6, I'd have to add 3 or I'm timesing by 2. So far I'm not seeing a pattern per se. So let's look at the next one. 6 to 10, I'm either adding 4 or I'd be multiplying 6 by 1.6 or 1.75 or something like that. 1.66 I'll say, I don't know, something like that. So I'm not seeing actually at all any sort of multiplication pattern. But I am starting to see that I'm increasing by 2, then 3, then 4. If I was following along with this, I would think that the next number is increasing by 5, and the next one that is increasing by 6, and that is exactly what is happening. So based on that, I should be able to predict the next few numbers. So we're going to do just that. We're going to predict the next few numbers. The next number is going to be a plus 7. So I'm going to predict that a 28 is my next number. My next one, I'm going to be adding 8 to it. So I'm going to say my next number is 36. After that, we're adding 9. So we got a 45. And the last one, we're adding 10. So we got 55. So that's kind of cool, fine and dandy. We have figured out our pattern. Essentially, what I'm seeing is every time we increase our figure size, we are adding that number to our previous amount of blocks. So as of right now, my current pattern is focused on the block before it, or the figure that was before it. But now we need to actually create an equation for that nth triangular number. What if we wanted to figure out figure 243? How many blocks does that take? We need to do that math. We need to figure out what that's going to look like. So we need to make an equation for this. I'm going to start out by making my equation for our 10th figure and see if I can generalize it a little bit. If I look at these steps and I remember how I sort of created them, I like to look at these as being big squares. I like to think about these steps based on area. And if I were to do that, I could finish this thing off, and I'm going to draw the rest of these steps that I didn't add in green. So math magic. So what I can see here now is I can see this full square that I didn't actually make, but I kind of used as sort of my basis. And if I were to think about this full square, I could think about this being a 10 by 10 square. So a 10 by 10 gets me 100. So this full square is showing me 100 little squares. Now, my actual number that I'm shooting for the pink squares is just 55 blocks. So if I think about 100, that's a little bit less than twice as much as 55. So I might as well just break it in half. Triangles, when I think about a triangle and the area of a triangle, I'm essentially cutting a triangle or a square of the same area in half. And so if I were to do that, I'm essentially cutting all of this right down the middle, breaking it up in half. So if I were to take this 100 and divide it by 2, I get 50. So that means I am lacking 5 total blocks. And if I think about this, what I'm lacking is this portion of each of these blocks. Because I know my half blocks that I have 10 of them, 10 half blocks, so I have 5 total blocks. But I've just lopped off the edges of all of these blocks. So if I were to look at the edges of all of those blocks and count them, I have a half, 2, there's 1, there's another half, there's 2, there's another half, there's 3, there's another half, there's 4, there's another half, there's 5. I've lopped off 5 blocks, all broken up into halves. So if I were to think about my number that I have right here for my side length and compare it to the number 5 that I need to add on to everything to get my total of 55 blocks, if I think about the number 10, that's a number divided by 2. 10 divided by 2 equals 5. So 50 plus 5 would get me 55 blocks. So bear with me here. I now need to generalize what I just did and see if that works for a more specific equation. So my first step was taking the base, I need to generalize it. So the base of 10, and I multiplied it by 10, by the height, and I divided it by 2. And then after that, I realized that I lopped off a bunch of my blocks. So if I lopped off those blocks, I had 10 half blocks, 10 divided by 2. So I now need to take this to a general statement. Instead of saying 10, what if I were to say n? So instead of saying 10, I'm saying n. So I have n times n plus n. And all of this is being divided by 2. I can see that I'm dividing by 2 here, and I'm dividing by 2 here. So I could rewrite this as n times n, which is n squared. Repeated multiplication will give me an exponent, plus another n, and I'm dividing all of that jazz by, by 2. So here is my general format for this particular situation. Let's see if this actual equation will work for some of our other blocks that we know of. So let's go back to our graph. I'm going to write my equation down, n squared plus n divided by 2, and see if that works for some of these other numbers. Let's try 7. That's always an awkward number. I don't know. 7 is just fabulous. So if we were to say 7 squared plus 7 divided by 2, we want that to equal 28. So 7 squared, that math is, I almost messed up. Sorry, it's my favorite number, 49. Then we still have our plus 7, and we're dividing by 2. 49 plus 7 will get us 56. We're going to divide that stuff by 2, and 56 divided by 2 will get us 28. And that is exactly what we need. So we need to now use this equation. Now that we know that it works for 10, it works for 7, I bet you it's going to work for 1. 1 squared equals 1 plus 1 would get me 2. 2 divided by 2 equals 1. It gets me the right number for even our first step. So this is our equation. We now need to predict what our 11th and 12th numbers would be for this triangular number sequence. So let's rewrite our equation. We have n squared plus n, dividing it by 2. So if n equaled 11, what would we get? We're going to say 11 squared plus 11 divided by 2. 11 squared equals 121. We're going to add 11 to that, and we're dividing by 2 after that. 121 plus 11 gets me 132 divided by 2, which will get me 66. And if I went back to my table, I know that I would be adding 11 to my next step. 55 plus 11 would get me 66, so that would be my 11th step. Let's predict what my 12th step is going to be. We know we're going to add 12 to this, so we can say 66 plus 12 would get me 78. So let's see if our 12th number would get us 78, and if so, we are set. N squared plus n over 2. Our n is equal to 12. We're going to say 12 squared plus 12 divided by 2 should get me, 12 squared is 144. We're going to add 12 to that, and after that divided by 2. Next step, 144 plus 12 is 156 divided by 2. 156 divided by 2 is exactly 78, exactly what we wanted. So our equation works, and we figured out our nth number. Kind of cool. Play around with this investigation homework if you feel so inclined, if you're not quite understanding how to potentially play around with this sort of stuff. Have fun with it. Enjoy it. This is sort of the fun part of quadratic patterns and quadratic equations. So play around with it. Enjoy. If you have any questions, as always, please ask. Thank you so much for listening and watching, and I will talk to you later.